Hi and welcome. Here where we are going to look at the polar form of the complex number. Okay, so figure 3.3 on page 193. Where's that? Page 193 shows. Okay, page 94, 193, figure 3.3 on page 193. Oh, here, okay, shows. So here we know that we can write this x. Okay, we can write x as r cos theta, and then y can be written as r sine theta. So rather than saying the complex number is x plus jy, we can say that it is r cos theta plus j r sine theta. Okay, so they say we have that, so rather than writing this, we can write this as r cos theta plus j sine theta, and then we can pull out the r here, which is r cos theta plus j sine theta, and this is called the polar form of the complex number, and it is frequently written as the polar form. Okay, r and then with that angle theta. Okay, so if you want to express the following in polar form, it's just simple. You just get the principal argument and then you get the modulus, and then so here what are we getting? We're getting the modulus, and then here we're getting the principal argument. The angle here is theta, which is just tan inverse of 5/12, which is that, and then in polar form, that is how we write it. Okay, so what about this one here? This is -3 plus 4j, so we have -3, and then this is 4j. So again, remember our principal argument here, theta, is going to be pi minus tan inverse of 3/4. However, this is negative, okay, because we are moving this side in the clockwise direction. Remember, theta is the angle between pi and negative pi, okay, and we are measuring it from the positive x-axis. However, since it is in this direction, that's why we add the negative, and it is going to be this minus that to give us this. Okay, all right, so that is what is here. Okay, so it's argument, and then they find it as that, and then they come to that, and then in polar form you can write it as r cos theta, and then plus j sine theta. Okay, then plus the j. What is the j? Okay, plus the j sine theta, but this is sine of -2.4, and you know that we can write it as negative j sine of that, because sine of negative theta is equals to sine of theta. Okay, oh yeah, they have used that. Using the results here, we know that cos of negative t is the same as cos t, but then sine of negative t is negative sine t. Okay, so what else? Multiplication in polar form. So we have z1 given as that, and then we have z2. So we just multiply z1 times that is going to be r1 times r2, then this times that, then you open the brackets. Okay, you open the brackets, simplify, and this is what we come up with. Okay, so remember, theta 1 is the principal argument for z1, and theta 2 is the principal argument for z2. Okay, so we can as well say this is it. Okay, z1 times z2 is simply r, the product of their respective moduluses, and then cos, then you add the principal arguments, then plus j sine, and then you add the principal arguments here as well. And then of course now you can see that the modulus of z1 and z2 is simply this one here. is simply R1 R2, okay, which is R1 R2, and which is simply the modulus of Z1 times the modulus of Z2. And then the argument of Z1 and Z2 is this one here, okay, it's theta 1 plus theta 2, which is the argument of Z1 plus the argument of Z2. Okay, and then please note that when using these results, we must take care that the principal argument here of Z1 times Z2 is between pi and negative pi. So we want to determine if we have Z1 and then we have Z2, we want to using that and that and that. Okay, we want to find that and then we want to find that, so we can as well get the principal argument for Z1, sorry, the modulus for Z1, which is that, and then its principal argument, which is that, and then Z2 its modulus, and then its principal argument, which is that. So if we want the modulus of Z1 times Z2, we know, we have already seen, it is just the modulus of Z1 times the modulus of Z2, which is 13 times 5, and which is 65. And then this one here is going to be the argument of Z1 plus the argument of Z2, which is this plus that, which gives us that or that. Okay, however, they say this does not express that the principal argument here lies within this range. Therefore, okay, the principal argument here, we shall, subtract 2 pi from what we have here, because remember we said that theta plus or minus 2 pi will represent the same point. So we have to make sure that whatever we have here satisfies that the principal argument lies between pi and negative pi. Okay, this geometric explanation, I don't know, may not be that necessary. What are they talking about here? Though division in polar form. Okay, again, division, we know what to do. You're just going to multiply times the complex conjugate. You're going to multiply the numerator and the denominator by the complex conjugate of the denominator. In this case, which is cos theta plus j sine theta, and then the complex conjugate cos theta minus j sine theta. So when we compute that, we should be able to get this, and then we know this identity here is 1, so we have this is it. Okay, thus if we have Z1 and Z2, then Z1 divided by Z2, we can have is R1 divided by R2, then you do that, and what else, this and that. Okay, so we can just a minute. Oh yeah. So, okay, so maybe we have R1 divided by R2, then we have cos theta 1 plus j sine theta 1, then times, okay, this is 1 divided by cos theta 2 plus j sine theta 2, but we know this in blue. Okay, we know this in blue is exactly what we have here. 1 over cos theta plus that gives us cos theta minus j sine theta. So that is why, so this one here in blue is simply going to give us cos theta 2 minus j sine theta 2, which is this one here in blue. Okay, then we multiply this times what we have here in green, that. Okay, and then we can expand. Do we expand? Yes, expand and collect like terms. Okay, so we come up with this expression, and then which can be reduced to writing. Oh yeah. Then we use the trigonometric identities here, because we know that cos theta 1, cos theta 2 plus sine theta 1, sine theta 2 is the same as cos theta 1 minus theta 2, and then this here is simply the same as sine theta 1 minus theta 2, using the trigonometric identities. Okay, you can refer to them in case you are not aware of that. So we shall in the end see that if this is z1 over z2. If you want to find its modulus is simply that r1 of this one here, r1 over r2. Okay, and then its argument is simply theta 1 minus theta 2. Okay, the argument of z1 over that is simply theta 1 minus theta 2, which is the argument of z1 minus the argument of z2. Again, you have to make the necessary adjustments such that this modulus here lies between pi and negative pi. Okay, yes, so the rest here are examples which you should be able to actually go through and then follow. Once you get the idea, the rest is just what is it? It is just algebra. Okay, so I guess you should be able to follow through that, and then in the next section we shall continue looking at Euler's formula here. Thank you, and see you in the next video.